two scheduled afternoon presenters. That will be Kaba. So Kaba, get ready. My name, I'll be chairing this afternoon session. My name is Professor Bebe from Animal Science. So let me welcome Kaba to give his presentation in exactly 8 minutes, so that our guest speaker from the US will have time to come in. Kaba, I hope your presentation is ready with us. Please come on.
Good afternoon. I am Keba Nyabali, presenting on genetic parameters for growth rates of the Ndama cattle in the Gambia. My co-authors are Dr. Thomas Moasia and Dr. Tobias Okeno. African animal trypanosomiasis is a disease caused by pathogenic protozoas. The vectors of this disease are of two important species. You have the Glossina palpalis gambiensis and the Glossina murtisan submurtisan species. This disease is caused through the bites of these testiflies, infesting them with the disease. And the major trypanosome species that causes this disease are the Trypanosoma congelens, Trypanosoma vivax, and also the Trypanosoma brucei. The disease causes anemia, pyrexia, weight loss, abortion, and also reduced milk yield, and eventually death if it's left unattended or untreated. Trypanosomiasis is among the top 10 diseases of economic importance in the sub-Saharan Africa, as it causes an estimate loss of $5 billion due to lack of effective control methods. However, a systematic survey and meta-analysis conducted in the Gambia with specialization on the field trypanosomiasis on ruminant productions showed a slight decrease of this economic loss. Current techniques that are employed to control AAT include vector control, chemotherapy, insecticides, which is expensive, and also it has adverse effects on the environment. And also, while the use of trypanocidal drugs can also be effective, yet they had a challenging effect, which is they are costly and many a time they are not readily available. Resistance of these trypanosomes to this disease has also been reported by researchers. A promising approach to African animal trypanosomiasis is the use of trypanotolerant breeds that are indigenous and adapted to this region of Africa, which is the sub-Saharan Africa, and also in the Gambia. These, the trypanotolerant breeds, one such of this breed is the Ndama cattle, that is known for its trypanotolerance. This breed is able to survive, reproduce, and weight gain under the trypanosome challenge environments without the need for trypanocidal treatments. This display of heritability is of utmost importance in order to be able to improve the traits under prevailing production circumstances. Genetic variance is a prerequisite considering genetic improvements in a population, and maternal genetic variance plays an important role in growth and survival of calves. These are indirect genetic effects that are inherited by offspring from their mothers or from their dams, and the effects of this maternal genetics are measured on the performance of the offsprings. These genetic contributions stem from the contributions of the dam and its impact on the economic importance of related traits such as birth weight, weaning weight, weight at calving, fertility, and calf performance, maternal care, amongst others. Focusing on maternal genetics and its effects on the related traits can enhance the overall efficiency of cattle herds. Previous studies that estimated genetic variance and also growth performances do not consider maternal genetic effects on the growth, on the early growth traits. Therefore, this study was to estimate genetic variant components and parameters for growth traits along the growth curve of the Ndama cattle in the Gambia. Materials and methods. The data was obtained from the central database of the International Livestock, the International Trypanotolerance Center, now called West African Livestock Innovation Center in the Gambia, Banjul. Traits of interest, that is traits of weight gain measurements of interest from birth weight, weight at 7 months, weight at 12 months, weight at 18 months, weight at 24 months, 36 months, and 50 months were extracted and analyzed for use. If the fixed effects analyses that are included in subsequent genetic analyses were determined using the following model, where sex, hard year season, parity, and age were used as fixed effects, were included as fixed effects, and also with their associated residual with each of the observations. Data analysis, a univariate animal model, was fitted in using BLOW-F90 package of MISAL 2018. The full model was fitted in, where fixed factors, additive genetic, maternal genetic, and maternal permanent environmental effects were fixed in with their related incident matrices. The assumption of the model is given below, where the G matrix is the matrices of the genetic covariance with the genetic maternal variances. And the assumption of the model is that there is a genetic correlation between direct additive genetics and maternal genetic effects. The results showing the least square means of growth for all the traits of interest, that is from birth weight all the way down to weight at 50 months, shows an increase of the means with the age of the animals, ranging from 16.93 all the way to 190.37. The results showing the estimates of additive genetics maternal genetics residuals, variants, direct and maternal genetic variances, heritability estimates of both direct and maternal heritability of the growth cell are shown below. The results show that the variance additive and the variance error, that's the residual, so the results to increase alongside with the age of the animals, with an exception of weight at 24. Both the additive variance show the increase of the weight of the animal and also the residual variances, except for weight at 24. And the heritability estimates for direct additives show to be low and moderate, ranging from 0.22 to 0.51, whereas the heritability estimate for maternal genetics was only important, and it influences only the birth weight and weight at 7 months, showing 0.11 and 0.20 respectively. So these results show that the heritability estimate suggests that there is a potential to improve the body weight of this Ndama cattle under the prevailing trypanosome challenges. To this regard, hence the heritability estimates for growth traits were moderate and range from 0.22 to all the way to 0.51, and it was highest for weight at 7 months, which had the highest influence of maternal genetics. And the maternal genetic effects were also important for birth weight and weight at 7 months, given an 11% and 20% of the total variation in these traits respectively. We conclude that if the genetic gain to be based on the response of genetic gain to be based on selection, then weight at 7 months would be chosen as the selection criteria. Hence, it has the highest heritability estimates and therefore should be used as selection criteria to improve the body weight of the Ndama given the trypanosome challenges. So to this regard, the study recommendation is there is a further need for research to estimate the genetic correlations between body weight and pack cell volumes, body weight and milk, and also body weight and fertility of the under the testy-infested environment of the Ndama cattle. I wish to acknowledge the Egerton University Department of Animal Science from the COED and all staffs, and also I wish to acknowledge the Gambia government for their support, financial support of my studies and also this research. I also wish to acknowledge COILIP. I've been using their resource center throughout my research, and also the West African Livestock Innovation Center for providing me with the data to be able to conduct this research. Thank you very much.
A few minutes before the guest speaker comes in, so what I'll do, I want to dispense with Keba so that we can still have engaging before we have the other presenter come in. So I'm allowing for only 2 questions for him. If there are any clarifications, point of clarifications on his presentation, or questions you have on his presentations. Obviously, you can also put them on the cards, but we'll allow for 2 here. 1, I see here. Please go ahead.
Okay, thank you. Kepa or Keba?
Keba.
Okay. I just wanted to know, these Ndama cattle, where they are, do we have any other animal that was not tolerant, that we can be able to measure the data against? An animal that is, how can we call it, susceptible to fly attack so that it can suffer from trypanosomiasis, so that we can be able to gauge this one was too much, this one is so low. What you have given is just one only. Is there anything else that we can be able to weigh against?
Beautiful. Any other one so that he answers them together? Kaba, come here. Is there any other? Okay, be precise.
Yes. Thank you for that question. The reason why the Ndama cattle becomes an important aspect of this research is that our cattle population, the Ndama cattle comprises of 98% of our cattle population, and it is the indigenous breed. But the other breeds, like the exotic breeds, that, for instance, the Frisians and other related breeds that are not of the indigenous of the country, whenever they are infected with this disease, it will affect them. Yeah.
Is there any other
of course
cattle that is not
of course
tolerant?
Of course. Those are the exotic breeds. Like for example, the breed I give, the Frisians and the other breeds as well.
Indigenous Frisian was imported.
For ours, Frisian is not an indigenous breed back home. And usually, when you compare the effects of trypanosurians on the Frisian and the Ndama cattle, it's usually the Frisians easily succumb to the disease than that of the Ndama cattle.
Beautiful. Have a discussion with him. You closer there, so that that can be. Give him a clap. Now, allow me. I want to move to our keynote speaker, whom I want to introduce. Coming to us from the US, it will be virtual. This is Professor Susan Wyke. Susan Wyke will be talking to us on the topic of human-centered approaches to innovative solutions that are in designing interventions for and with Kenyan youth who have type 1 diabetes. Professor Wyke is an associate professor in the Department of Media and Information at Michigan State University. She is also affiliated with the MSU Global Center for Food Systems Innovation, which is funded by the USAID in their Higher Education Solutions Network. Her research focuses on information and communication technologies and development. Professor Wyke received a PhD in human-centered computing from Georgia Tech, and a MSc was from Cornell University. Her undergraduate degree was in industrial design from Carnegie Mellon University. She teaches, the courses she teaches include human-computer interactions and experiences design, information and communication technology for development. Our research and teaching are in the area of human computing interactions, computer-supported cooperative work, information communication technology and development and design. She's currently working at this research center and the labs that are affiliated to Health and Risk Communication Center. This is the person we are going to have speak to us on human-centered approaches to innovative solutions, drawing from the Kenyan youth that have type 1 diabetes. So, Susan, we want to allow you enough time to talk to us, take us through. Please, the floor is yours. For the audience that are on the virtual, please put your questions through the chat. They will be shared with Susan. Please proceed.
So thank you, Habari Zenu. Thank you for inviting me here. Can everybody hear me?
Yes, they do.
Okay, good. Make sure. Okay, thank you again. It's an honor to be here. I want to thank Dr. Miriam Chirimbu for inviting me. I'm grateful for this opportunity to continue to build on the strong relationship between Egerton and Michigan State University. Today, I'm going to share my perspective on this conference theme of innovation and innovative solutions to problems for the 21st century. I'm going to talk about a project that's been funded by the National Institutes of Health in the United States that's aimed at developing these human-centered interventions for youth with type 1 diabetes. And as I talk about this, I want to draw attention to some broader lessons that I think will apply to any project in any field about innovation. So I just want to elaborate a little bit about who I am. Like the previous speaker said, I work in a field called human-computer interaction, which is a research discipline that broadly examines the design, use, and evaluation of technology. I also work in a growing field called information communication technology and development. And this field broadly examines how to design technologies for users in so-called developing regions or low and middle income countries. To do this research, I primarily conduct fieldwork in Kenya. I've been fortunate enough to be able to travel to Kenya for almost 17 years to conduct the research that I do. And as many of you know, Kenya is an exciting place to be studying technology and innovation. Nairobi, your capital, is referred to as the Silicon Savannah because of the tech startup scene there. A number of US-based technology companies like Microsoft, Google, and IBM have an established presence in the country. And over the course of my career, I've worked closely with students and collaborators from various disciplines, including economics, anthropology, and computer science, as well as people and organizations in Kenya, including faculty at Egerton University, to do this research. And I've grouped it into these three categories that you see here. Much of my research is focused on the challenges that Kenyan women, particularly in rural areas, can encounter when using their mobile phones. I've also conducted studies examining social media, in particular Facebook, how that's used in parts of rural Kenya. I have a body of research that explores how you can use participatory methods, such as sketching, to explore how Kenyan farmers might imagine technological solutions to their own problems. This is a project where we're working with farmers to redesign their djembe or hand hoe. And these projects have been guided by this human-centered design process. And that brings me to what I'm going to talk about today. Human-centered design is an approach to technology development that involves putting people, their concerns, and their activities at the center of the design process. So again, rather than letting technology sort of lead the technology development process, you base your decisions on understanding people. This approach to technology design has been widely used in computer science fields for software development, but it's being increasingly used in other fields, including public health. The approach generally has three phases that you see in this diagram here. The first is this understanding phase, so conducting interviews and field work to understand the people that you're designing for. Once you've conducted this work, then you take this information and use it to generate technological concepts using sketching and prototyping methods. And then in the final phase, you evaluate your project outcomes to see if it actually responded to the users that you interviewed in the first phase. So in the rest of this talk, I'm going to discuss how I used this process to guide a project that resulted in the innovation that you see here in red. And it's a diary that was designed for and with Kenyan youth with type 1 diabetes to help them manage the disease. There's one more important aspect of this project that I want to mention that I think is very much related to the conversations about innovation. We were tasked originally in this project to design a mobile phone app. But for reasons that I'll go over later, that didn't make sense. And I just want to put that out there before I continue. I also want to emphasize that this was a highly collaborative project. I'm grateful to be able to talk about it, but I could never have done this work without my partners at Michigan State. We've had very strong collaborators, the Kenya Diabetes Management and Information Center based in Nairobi. our partners at Rural Outreach Africa, and then an incredibly talented team of Kenyan designers who've also helped us with this project. So this project started in April 2021. During that time, we were finally able to travel to Kenya following the COVID pandemic to begin this project. Like other African countries, type 1 diagnoses are rising in Kenya, especially among middle to late adolescents or youth. Type 1 diabetes is a non-communicable disease. It demands continuous self-management throughout one's life. This management includes monitoring your blood sugar levels and injecting insulin multiple times a day, adhering to a balanced diet and exercising regularly, and also regularly meeting with a healthcare provider. You can lead a normal life if you follow these guidelines, but if you don't, poor management can result in serious health complications. And it's estimated that in Kenya, 50 to 70,000 youth have type 1 diabetes. This number is rising. It's also likely larger because getting exact numbers about how many youth have the condition is tricky. So in this project, we focus on youth and developing interventions for them because prior research tells us that youth encounter challenges managing their type 1 diabetes at this development stage. There are issues of stigma and misunderstanding at school, and also their developmental challenges that come as you go through puberty. For this project, we collected data in 2 sites. We worked in Nairobi, and we also worked in a rural area in Vihiga County. So again, we followed this human-centered design phase for our project. And to begin, using this understanding phase, our goal was to learn as much as possible about youth and how they manage type 1 diabetes. So just to do this, we interviewed 24 youth, 12 in Nairobi, 12 in Vihiga. We also talked to their parents and caregivers. We talked to doctors. We talked to school teachers. And in total, we interviewed 56 different people. And again, our goal was just to understand as much as we could about how youth were managing type 1 diabetes. This is my colleague, Jenny Olson. She conducted many of the interviews. We went to participants' home. We asked them about when they learned that they had diabetes, how it impacted their family and everyday lives. We also observed how they managed it in their homes, and observed these makeshift insulin storage units. Insulin has to be kept cold. Not everyone had access to a refrigerator. And again, one of our key findings, and this is relevant to what I mentioned earlier, was that, again, we were funded to develop a mobile phone app. But what we learned was that nobody was using their mobile phones to manage their type 1 diabetes. And again, I imagine most of these findings will be familiar to many of you in the audience here. Particularly in the rural areas, most people had a Kambambe or a simple phone, particularly women. So they weren't using their phones to use these apps to help manage their type 1 diabetes. And so pursuing an app didn't seem like a reasonable outcome of this project. So we shifted gears. I briefly want to show a video from one of our participants because I do think she does a better job of explaining some of the challenges with mobile phones than I do. So let me see if I can get this video.
How many people don't have Wi-Fi or bandwidth? If we want to reach people in China, but we don't just solving a problem for Nairobi. We need to go to the rural areas where I come from, Nyahururu. There are people who don't have internet bandwidth, for them it is an unnecessary luxury. So that one might be a challenge, but of course, there are cheaper providers like telecom. We could strike a deal maybe to solve that, but still it will be a problem for many people. The cost of a smartphone. For you to have an app, you need a smartphone. You need a couple of $1,000 of shillings to purchase one. Maybe if we solve this issue, we could come up with the government, we provide the smartphone, which is very ambitious, but that causes an issue. The other issue is not everybody knows how to use a phone, especially in the rural areas. They only know how to speak. They make a mother in Colonia South. And I go to Kushika and Ghana. It's just big and color. So the literacy difference could be an issue, but it could be solved with training and maybe figuring around network in remote areas and problematic. But I'm not when you go, you know, nobody will get you on board unless now you start changing a network, another network, but still you're not available full time. Then accessibility in schools, our issue is the youth. Like my son is the how will you use it in school? So it could be an issue, but then our group suggested that if your youth has an diabetic issue, then we need to strike or to have a policy that they can make the call with the nurse so that we can be monitoring the app. And you will understand once I get to the.
So again, remember this human-centered design process is about understanding people and their needs. So this sort of anecdote from one of the mothers of one of the youth, I think really illustrates why pursuing a mobile phone app didn't make sense. And again, I imagine many of these challenges are familiar to many people in the room. So again, we gathered this information. We decided that it didn't make sense to pursue a mobile phone app. So knowing that, we entered the next phase of the process, which was this ideation process. So working with the youth, working with their caregivers to come up with potential interventions or ideas for interventions that did respond to their needs and their context. So to do that, we held these 2 design workshops, again, one in Nairobi, one in Vihiga. We brought doctors and healthcare workers together with the youth and their parents. They engaged in brainstorming exercises. We gave them markers and paper, and they drew many, many ideas. And again, these ideas were very much based on the type of interventions they thought they needed. And this diagram sort of shows sort of the outcomes of this process. So you can see during the workshop, we generated roughly a dozen ideas. After the doctors and the research team and the design team reviewed these, we thought that it made sense to pursue a diary. A consistent theme in our understanding phase and in the workshops was that the youth and their doctors really wanted a way to monitor their glucose levels. They wanted to be able to write down what they were eating, their moods and their activities, and again, to figure out how it was impacting their diabetes. So the design team created these first 3 versions of the diary. Then again, you know, after we analyzed the data, talked to some more doctors, we eventually developed the first prototype that you see here with the blue cover. And this was about a 3-month process, going from the initial design ideas to some first rough prototypes of the diary into the one that you see here. So then we engage in the final phase of this process, which is the implementation or the evaluation. And the goal of this phase was to evaluate our intervention, to see if it was usable, to see if the youth were interested in using it, if it was attractive. And again, the purpose of this diary was to record their blood glucose levels over time. Again, this is a really important activity that if you have type 1 diabetes, you must engage in. You must keep your blood sugar levels within a certain range. So again, giving youth the tools they needed to do that. Another thing we were interested in doing was seeing if we could increase knowledge about type 1 diabetes. So in addition to having activities that let youth monitor things, there was also a great deal of educational content in the diary, and I'll share that in the next slides. So again, we evaluated our diary. Again, we held another round of workshops, brought the youth back to we were working in hotels in Nairobi and in Vihiga. We gave them this prototype that we developed. We asked them to fill out the pages, provide us with feedback. We also administered a short survey. I think another point that I also made was that we worked very closely with doctors in Nairobi to also make sure their input was accounted for in the diary. I'm not a medical doctor, so it was important to make sure that the information in the diary was accurate. And you see the doctors we worked with in the slide here. So this was a short-term evaluation, but some of the findings were generally positive. Youth and their caregivers liked the diary. They liked the images. It looked like their context. We had pictures of ugali and the food that they ate, and that was different from sort of other diaries that they had seen developed in the past. There was an appreciation for information about how to handle type 1 diabetes related emergencies. Our survey suggested that the youth in our study were regularly using the diary. During this evaluation phase, we also received a lot of feedback about changes that needed to be made to the diary, and we've since implemented those into another prototype. So this is what you see here, the final version of the diary that we developed. We completed this in this final version was developed over our summer, so in about June of last year. We returned to Kenya and we presented the diary to the youth that helped develop it. You see at a presentation ceremony in Vihiga County, presenting the diary to the youth with type 1 diabetes. We were grateful because the Vihiga County Governor, Dr. Wilbur Otichilo was able to join the ceremony, and that was exciting. You see him in the picture here. Again, just showing you some of the pictures of the diary. And again, these were all developed with the input of the doctors, the youth and their caregivers, adding the emojis so they could keep track of their mood, guidance on proper foods to eat, how to appropriately inject insulin. And again, I want to sort of come to the end of my talk, and what are the takeaways that I think are particularly relevant to this theme of innovation today? Well, an advantage of using this human-centered design approach is that it leaves you open to unexpected solutions to problems. And, I think what's most significant, and one thing I really want to make clear, is that we learned that digital might not always be the best. I think there's this tendency to think that, innovation has to have AI or be a mobile phone app. But that might not always be the case. Again, I think this is a really important point that if you don't remember anything else from my talk today, I want you to remember that. Again, innovation shouldn't only focus on developing more sophisticated technological solutions. I think it's easy to buy into this hype around AI and mobile phones. But I want to make a case that truly innovative solutions are human-centered, and they respond to the needs of the people you're designing technology for. And again, that's the most important thing I want you all to take away from this talk today. So we've since completed, we've run out of funding for this project. We're working to try to get more funding so we can conduct a more robust evaluation of the diary. And we're hoping to eventually find enough money to distribute the diary to 50,000 youth in Kenya with type 1 diabetes. That's where we are now. So that concludes my talk. Again, I want to thank my collaborators at DMI, Rural Outreach Africa. I also want to thank the project funders, which were the National Institutes of Health. So I'd be happy to take questions and hear your comments. And again, I want to thank you for this opportunity, and thank you, Miriam, for inviting me, and thank you for your time.
Very well, Susan, keep on there, stay on there. We shall interact with you just immediately. Please give us a clap. We shall take, we filled 3 questions before I go to online, if any. 3 questions we can fill. Is there any from the floor? I'm I'm seeing one hand behind, 2, 3. Please take the microphone there. Yes.
My name is Nancy Maderi, and I thank you for the presentation. It is.
Susan, do you hear? Do you hear?
Yes. Yes.
Go on.
It's a very informative presentation. Now, the diaries that you have designed, once it is full, the child has basically, I'll assume that it's a diary that will go for maybe 3 months, 6 months, or even a year. What happens to that diary? Is it possible that somebody can come and scan and save the data, which can be linked to that particular child, which means that it would be actually be embedded with a scannable code that would then be lifelong data for that child?
You're taking it
Thank
a
you,
step ahead,
Nancy.
eh?
That's a wonderful question, and I
Nancy,
deeply
Nancy,
oh.
hello. We field the others so that you answer them at once. Eh?
Oh, fully. Okay.
Yeah, just take note of it. The second person was somewhere there. Yes.
Thank you very much for that presentation. I also really love the idea of the diary. I think it can go a long way. My question is, the diary is one thing. Of course, it helps us to understand what maybe the child needed to do in a particular day. But how do we make sure that the child actually has the right diet of whatever is recommended so that they take that? What interventions are in place to ensure that this diary doesn't just remain as a diary, but it's actually applicable to the situation of the particular children? Thank you.
Actions complementary to the diary. The last question behind there. ICT, check if there are some questions on the virtual.
Thank you, Susan, for the presentation. I have one question. Is it possible also to provide the digital version of this diary, especially for these people who can access their mobile phones? Thank you.
Susan, you can now pick on those.
We have a comment.
Now, thank you so much, Susan. I want to comment on your last point, that digital might not just be the real solution. And I'm looking at what you are presenting on diary. Reason being, I've worked with one particular kid who was fond of writing diaries. The kid has access to computer and what have you, but this kid is talented. And therefore I realized in a way what you're trying to say is we can actually kill a talent if we insist on maybe digital. I don't know if that is one of the messages you are bringing out. But I'm also asking this because of our new curriculum where we are really insisting on going digital. So maybe you'll comment on that. Thank you.
Susan, you can now respond to the four.
So thank you. I appreciate all these questions. They're very thoughtful and noted. I want to first address Nancy's question, which is a very good one. So Nancy's question was about how long the diary is and if there could be a digital component. And so yes, the diary lasts for 3 months. So ideally, the youth would take the diary to their doctor's appointment every 3 months. And you're exactly right. So I do think, maybe I should have revised what I was saying to say the solution shouldn't be just solely non-digital or digital. Maybe the best solutions are in between. And I think Nancy's comment draws attention to that. You're right. In the future, we could integrate a scan, a QR code into the diary. DMI in Nairobi does have a database of the youth and their medical records. So if we could somehow integrate those things together, I think that would play a promising way to move forward. So I guess to sort of amend what I said previously, maybe the best solutions are a mixture of both, the digital and non-digital. I want to come to the second question, and I apologize, I didn't catch your name. But another well-taken note. One of the things that we did learn is that no intervention, no amount of technology is going to address some of the underlying problems that make it difficult for youth and their caregivers to manage diabetes. A mobile phone app or a diary isn't going to give you the money you need to get to the healthcare provider if you don't have it. If insulin isn't available, it's not going to address that problem. Like this particular person said, if you don't have access to the right diet that you need, a diary or a mobile phone app isn't going to fix that. So again, that's well noted. There are certainly larger systemic problems that we cannot address and that are crucial to managing type 1 diabetes in Kenya. So that's a point well noted. That's a limitation of these efforts. The final question, and I think I started to begin to answer this by responding to Nancy's question. Maybe it isn't just digital or non-digital, but maybe the way forward is finding a balance of both and figuring out which makes sense when. Coming back to Miriam's last question, and again, I think this starts to begin too. I think there needs to be a balance of the digital and non-digital. There are apps available for youth with diabetes, and we found that some of the youth in Nairobi were using these, but issues of airtime come up. They can't keep the airtime on their phones, required to use it. Some don't have smartphones. So those are still challenges, but there are apps out there, but we didn't find anybody who was using the digital apps. But maybe it's just a matter of time. So again, wonderful questions. I hope that I answered them all. I do want to, and I do also want, the diary is available for download. I can share the website. So that's one way we're working to make it accessible. But maybe the solutions, there should be a mix of digital and non-digital, and not, we shouldn't go either or.
Thank you, thank you. Please clap for her again. Susan, we hope when the data available on the 30,000 youth you are targeting, you'll come back to share with us.
I will definitely be back at Egerton. We're having a group, I'm hosting a group of Egerton students at Michigan State next month, so I will continue to, this relationship is very valuable, and I hope to continue building it between Michigan State and Egerton.
All the best, all the success. Thank you. We now get back to the different sessions. In here, we remain with those that are under Lord Egerton. The other group will proceed to Niswit. Under here, let me know if Hagenimana, is he there? Okay, Mutinda. Is Mutinda there? Is Mutinda there? Okwa? Is Okwa there?
Yes, I'm on. Yes, I'm online.
You're online. Good.
Yes, thank you.
We'll come to you. Hamed? Is Hamed there? Is Hamed there? Masai?
He's one of my colleagues. Ahmed is one of my colleagues here, so he's around. He just moved out of the computer, but he's online. I'm with him. He's around.
Hamed is around. Will also be online, eh?
Yes, yes.
Beautiful. And where are you?
Thank you.
Where are you?
I'm in Hungary.
Masai, is Masai with us? Beautiful. Muhindo and Opondo. So it's only two that we are not sure. So that helps me to manage the time. I'll proceed with Hagenimana, please. Hagenimana will be presenting about valorizing potato peels, waste into bioactive compound peels, extract in Rwanda. Peel, being valorized. Eh? Please come in. Please do write the questions you have. Do share them in these papers.
Recording in progress. Recording in progress.
Good afternoon, everyone. Welcome to my presentation on the work of the part of my PhD, valorizing potato peel waste into peel extract containing bioactive compound in Rwanda. I'm with my supervisors, Joseph Anyango, Patrick Muriro, and Clement Bitwaiki. I'm going to pass you through this outline presentation, starting with introduction, talking about the potato, how it is very important. It is a staple food whereby worldwide it is the third one in the rank as important. And we can see that about 1.3 billion depending on potato consumption, and it is a crucial for economic growth.
Recording in progress.
In developing countries, and we can see that in that right figure that especially in developing countries there is a progressive increase, and in East Africa it is increasing, and by 30 we see that developing countries will more productive than developed countries. Potato in Rwanda is a priority crop for development and food security. Excuse. I'm not seeing the slide.
ICT, please come assist here.
Okay, it is done. It's okay. I was saying that potato in Rwanda, it is a priority crop for food security and development. In Rwanda, it is the second one important after cassava in providing energy, and there have been increase in production whereby more than 167% was increased between 2013 and 2019. It is highly consumed in Rwanda. Imagine 125 kg per capita per year. It is highly consumed in Rwanda. Potato is still important for human, whereby it is processed in main product such as boiled potato, potato puree, roasted potato, French fries, and chips. This potato worldwide also, there is a trend in the global market whereby it will become a staple food at the same time, a cash crop. However, this kind of product, it generates potato peels. This waste is interesting, at the same time important byproduct. It is important byproduct to consider because about 7 to 140,000 tons are generated by year, but this generation, this quantity will increase with time, because by 2030 we generate potato peels will generate about 8 million tons. The problem is that these generate potato waste, they are disposed of as zero value waste. Even can potato peels, they are wasting, they are losing the important value as those figure down that they are peeled but they are wasted. So this is these peels, they cause problem of generating like the factor of greenhouse gas emission, whereby by 2030, about 5 million tons CO2 equivalent will be generated, and it is a handling burden to processors. However, there is good news for these peels, because it is interesting that by research, these potato peels waste are being focused on, because from 2018 to 2019, there have been increasing research about this potato peel, whereby they are using as biorefinery, it is a little bit lower. But what other research focusing on? They may be focusing on using to extract some bioactive compound, because potato peels are among other agricultural residues. It is a greater source of bioactive compound for health and industrial application, whereby you can use them in the processing of food. They can be used as antioxidant. They can be used to process for pharmacological purposes. So potato peels are very important. Some of those chemicals structure, you can see the structure of them. They are different among a bioactive compound. They are phenolic compound. Also, there is glycoalkaloids. This one is not really good for application in food. So it is again interesting, these potato peels, because it fits in the trend of a paradigm shifting from traditional practice to agriculture bioeconomy and circular economy through industrial waste management. So if you can see that figure, crop residue management, there is a trend from traditional practice to bioeconomic zone, where you can find waste valorization, whereby we need to valorize these potato peels. How about Rwanda in terms of potato peels valorization? These peels are disposed of in the environment, and there is a scarce information on research and evaluation of these peels. And for Rwanda and worldwide, circular economy-based agro-waste management is needed for each country to cope with future requirement for the sustainable food system. So that's why the objective of this study was to valorize potato peels of 5 different potato cultivars, which were selected as important potato cultivars, and to extract bioactive compound extract using 2 extraction method. And also the specific objectives to determine the effect of potato cultivars and extraction method on the content of bioactive compound, especially glycoalkaloids, phenolics, flavonoids, and anthocyanin. Materials and method, the study area of this study is Rwanda, with those kind of information. But what I can mention is that in Rwanda, about 15 potato cultivars are locally grown. The potato cultivars selected had different characteristics and even the color, so that
Recording in
they
progress.
may influence the peels, the content of the peels.
Is that
processing potato peels extract was followed the channel of washing potato and peeling
Recording
them,
in
drying
progress.
them, grinding them, extracting them using the 2 specific method, and drying the raw extract to remove some solvent used. And the phytochemicals was analyzed with different methods, and the statistical model used was that one was considering the potato cultivars, the extraction method, and even the interaction. And 2-factor ANOVA was used to separate the mean the test was used. As a result, there they are, according to potato,
Recording in
depending on
progress.
potato cultivars, we can find this, that depending on the chemicals analyzed, they have been, there was the difference, significant difference among potato cultivars, and this was due to potato maturity period, the skin, and fresh color. Also, we can consider the genetic trait. What you can see is that the Kuruseke potato cultivars has like the favorable amount concentration of phytochemicals, but excluding glycoalkaloids because this one is not favorable for food application. Considering the extraction method, we found that there was a significant difference between the two methods, the coction method and the indirect urethra-assisted sound-assisted extraction. As the conclusion, before I conclude, even the interaction effect has the same trend. So as conclusion, processed potato extract contain a bioactive compound suddenly different concentration due to potato cultivars and the extraction method used. Use the extraction method, the two and what I can mention is there was the novel method and traditional method, but the both method produced peel extract with the safe level of glycoalkaloids for food application, whereby Kuruseke peels with the novel method, indirect urethra-assisted extraction, and the decoction method demonstrated better performance. However, there is a need for further investigation, improving the extraction yield so that we can process a quality peel extract in Rwanda. With that, I hope that with these potato peels, there is a hope that a victory in our green innovation and ingenuity toward the twist circular economy for human and environment benefit. I would like to recognize acknowledgement for Egerton University, SESAM for sponsoring my PhD program, University of Rwanda to provide the facility for lab analysis, and also Rwanda Agriculture Board to allow me to get the sample of potato cultivars. And also I thank my supervisors for their guidance. Thank you very much.
Also thank me for giving you more time. Eh?
Thank you very much.
Give him a clap. We shall proceed with the other two before we have feedback with them. So please keep the questions. You will come back. I'm advising those who are coming back, please spend less time on the introduction, spend more time on your methodology and the results. Spend much time on what you did and what you found and the implications. Toe down on the introduction. Mutinda, are you there? Are you there now found? If you don't have Mutinda, we shall have Okwa. Okwa, you are online, are you? Okwa, you are online, are you?
Unfortunately, I have been allocated again. I see myself in a different room. I don't know what's happening, but I'm with a colleague here in his computer. So now I don't know what's happening actually because they keep shifting us from one session to another. So I don't know whether I can present using his computer because my computer, I'm in the other session. I don't know how they shifted me there. Okay, so what do I do?
How do you help you? What help you?
Can you shift? Okay, now maybe help me and shift me to this session from the other one. Send me a link.
Do you hear what he's saying? Oh, please get him back here. Get him back here. He's in another room. That's what he's saying. Yeah? But this way is.
Yes, that's why he's speaking to us. What is his name?
Mutinda, are you available? Mutinda? Okwa, You can use that laptop. Can you?
Fine. Then I can use, no problem. Can sit here.
Then go ahead.
No problem.
You have 7 minutes.
Thank you so much.
In the meantime, Mutinda, wherever you are, please alert us. So share your screen with us. Mr. Okwa. Is it Okwa or Oshua?
Ochua.
Huh?
Ochua.
Ochua.
Please give me your flash. Ochua.
Please, Ochua, we have 7 minutes.
Oh, yeah. You are not sharing from there. Share from this side.
Help it.
Since I'm using someone's computer, so I have to transfer it to this computer there.
You have to share from your side.
Yeah.
Do you have his presentation with us? Then we upload it. Sure. Sure, we don't have your presentation with us, so can you share yours?
Sure, I'm going to share from here. Just a second.
You're allowed to share, so proceed.
Thank you so much.
Sure. Sure, is that you?
Yes, I'm here. I'm now about to share.
Nobody there to help you?
No, I'm able to do it, no problem. I was still inserting the flash, so I'm ready to go.
So if we, you are there. Sure, you are there now.
Sure.
Go to presentation mode.
Yeah.
Beautiful.
Thank you so much. Good afternoon, everyone. Thank you so much, Chair, for being patient with me, because I don't know exactly how I was shifted left and right, but it's fine. My name is Akasairo Chua. I'm from the University of Debrecen. I'm going to make our presentation titled Biostimulating Effects of Bacillus simplex bacteria on chemical yield and grain yield of maize under surface irrigation. Just to highlight, this was just a preliminary study that we aimed at determining the potential of this bacteria to improve either vegetative productivity or yield, so that probably we could use it directly or do it with other interventions. As we are all aware that maize is one of the most important crops grown globally that contributes to food security. However, its production is constrained by a number of abiotic and biotic stresses, and among the abiotic stresses include deteriorating soil fertility. So many measures have been done to ameliorate that effect, the effect of deteriorating soil fertility on crop production, especially maize. For example, the use of chemical fertilizers, which we all know has been criticized because of some other consequences or effects, especially when it comes to pollution. Therefore, some of the measures which are being encouraged include using biostimulants, which could be microbial or non-microbial. Now, these biostimulants, there are controversies in the available literature. They can yield positive results, sometimes negative or even null results. In this situation, currently here, some of the biostimulant was developed as a novel product. However, its efficacy under field conditions is not well understood or not yet tested. So in this preliminary study, we wanted to test its effect under irrigation because we already knew some results under drought stress. The justification for this was for 2 reasons or 3 reasons. The first one was that we wanted to determine the effect so that probably it could be recommended for farmers to use, or it could be developed further, or if the effect was suboptimal, it could be utilized together with other agrotechnical inputs. And to be able to get these preliminary results, we conducted a preliminary study in 2022 using a randomized complete design block. This was a field experiment, and we just tested. Of course, there are other treatments, but for this presentation, I'm just presenting this. We tested Bacillus simplex bacteria versus a control. The irrigation was applied based on precision methods, where water was supplied depending on the need, and the amount of water supplied was 413 millimeters. The assessment was done using, basically, we assessed two parameters. First, the photochemical yield of chlorophyll fluorescence parameters, and then the yield itself. As I said earlier, we wanted to know first whether the effect of this biostimulant on maize productivity vegetatively would be the same effect on the final yield, so that we could take decisions either to ameliorate it at the earlier stage or consider it to use at a later stage if the yield effect was significant. This data was collected using a modulated chlorophyll fluorimeter, and the measurements were done standard protocols as per the manufacturer of this equipment. Data was analyzed. First, data was collected data on minimal fluorescence, maximal fluorescence, variable fluorescence, photochemical yield, and electron transport system. And this data was analyzed using a t-test, of course, after testing the assumptions. But for the presentation, we presented basically most important parameters, which is electron transport system and photosynthetic efficiency and yield. In terms of our result, first of all, that was to look at the weather and the climate conditions. It was one of the worst years here, where we experienced a little bit of high drought stress. And consequently, when we tested the photosynthetic efficiency of this biostimulant, we realized that they had no significant effect compared to the control. But when you look at it progressively, there was a marked reduction in both of them, both treatments at the VT stage. The reason for this was not clear, but probably we assume maybe it was, not assuming, but maybe it was a photochemical, because of photochemical inhibition. Electron transport system as well was not significantly different from the control when compared, the two are compared. But again, you can see the progression that at the VT stage, there was a marked reduction, even when treated with the Bacillus simplex bacteria. I should mention that often, of course, literature shows that this bacteria especially improves the initial establishment of the maize. However, sustaining its productivity at later ages may require some other inputs. In terms of the yield, the same results. The yield also did not differ significantly between the Bacillus simplex bacteria and the control. However, looking at it in terms of increment or change, we discovered that at least the Bacillus simplex bacteria improved the yield by 26%. And just mapping the hollow yield, generally, we discovered or we revealed that as the photosynthetic efficiency increases, especially on Bacillus simplex bacteria, there is a potential to get a yield of up to 16 tons per hectare. In conclusion, therefore, being a preliminary study, we reported that we discovered at the end of the preliminary study that Bacillus simplex bacteria did not improve significantly the photochemical yield and the grain yield under irrigation. And from this, we noted that early detection of limited effects of this bacteria on photosynthetic efficiency could provide insights into the application of remediating measures before the final yield is realized. So subsequently, the product or the results we took from this study is that we are able now to carry out further experiments, which were already done. Together, we combine now this bacteria with other agrotechnical inputs to try to improve its effect. I acknowledge and appreciate my co-authors, Mr. Brian Semugeze, Dr. Chabi, Bojtor, Dr. Eilish Apad, and Professor Andrew Hashani, who happens to be my supervisor. And well, I also appreciate, acknowledge the funding provided by Hungarian Ministry of Culture and Innovation, provided to fund the study, and our University of Debrecen for the support in terms of payment of logistics and participation fee, and Egerton University for organizing this wonderful conference, and also you, the audience, for giving me the chance to present to you. Thank you so much for your attention.
Thank you, thank you. We want to ask you to hold on, because the next presenter is also online. After that, then we'll call you to have a feedback with the audience.
Sure, yes, thank you.
Which country are you from? Where are you presenting from?
I'm presenting from Hungary.
Hungary.
Yes, but I'm from Uganda.
Beautiful. So remain awake, eh?
All right.
Thanks. The next presenter is also online, Hamed.
Yeah.
Hamed, are you there now?
Yes, yes,
Beautiful. Before Hamed comes, is Mutinda now found? Is Mutinda now found?
No, Mutinda is still not available.
He has disappeared again. If he's found, we'll slot him in. So, Ahmed, please proceed. We are giving you only 7 minutes to make your results shared with us.
Okay, thank you very much.
Thank you. Thank you.
My name is Ahmed. I'm a PhD candidate, Victoria School of Food Science, University of Debrecen, Hungary. The title which I'm going to present today, it is Macroelement Concentration in Baobab Leaf from Sudan, Implication for Human Nutrition. Baobab tree Adansona digitata have long been revered for their ability to thrive in arid and semi-arid environment, providing efficient resources for communities in our countries, in our African countries. The Adansone digitata originated has been found in West Africa, but it is immigrated throughout the tropical part to the other continents, as you can see here in this map. Adansone digitata has been distributed in several countries, as I mentioned before, in Africa, but mainly in Sudan and Kenya. In Sudan, baobab is mostly found in the sandy, clay, and rocky soil. And in Kenya, it is found in bushland, woodland, and wooded grassland. The Adansone digitata called multi-purpose tree because it has the useful parts, such as fruit bulb, leaves, and seed oils. Even bark is useful for medicinal purpose. But Adansone digitata is known for the fruit bulb, but the nutritional potential of its leaves remain unexplored. That's why this study explored the variation in macroelements concentration in baobab leaves across 3 distinct sites in Sudan, which is called Mountain M, Plainland B, Wetland W, to highlight the possible nutritional importance of this extraordinary tree. Our study started from Sudan, and this is the map of Sudan, and it is covered 2 different regions. It's the Blue Nile and Kordofan regions, which baobab is distributed there. And from each region, we collected the sample from different parts. It is a plainland here, and wetland and mountain. So the laboratory work was conducted at the Food Science Institute, University of Debrecen, Hungary, and ICP-OES was used for elemental analysis. The descriptive analysis showed that there is some differences of the mean concentration of microelements, such as you can see here, the iron was highest in the site M when comparing the microelements among Blue Nile, but when comparing the means among the sites, the site B shows the highest means. The result of manganese was highest in site B when comparing the manganese among different sites. The copper expected variation across the different sites and the highest mean concentration was observed in site W, and the site W is a wetland. Here you can see the differences, and the wetland, it was the highest. The zinc exhibited variation across the different sites, and the highest mean concentration was observed in site W, here. Even when comparing sites among Blue Nile, even the site W was the highest. To approve differences, t-test and one-way ANOVA was used, and the t-test showed that there is a significant differences among mean concentration of manganese, iron, and zinc, but there is no difference, significant differences for the copper. Comparing the concentration among different sites, the one-way ANOVA showed that there is no significant differences except in copper, as you can see here. So findings of this study to emphasize the need to consider specific sites and regions factors when we are assessing the dynamic of microelement concentration in baobab leaves. And then understanding this variation helps to refine dietary recommendation and nutrient intake. This research contributes to a deeper relationship between the environmental and nutritional significance in the diverse sites and regions. So further investigations is needed to study the mechanism underlying nutrient uptake of the baobab trees, the cascading effects on ecosystem dynamics, and that can promise for advancing our knowledge of nutrient cycling in arid and semi-arid regions. Finally, I would like to express the support and University of Egerton for having me in this conference. Thank you for your attention.
Mic check.
Thank you. I have two questions, one for the Rwanda presentation on the pills, and the other one on the last presenter, that is Hassan. I like the idea of exploring the use of pills. I think this is Irish potatoes, if I'm not wrong. But I never heard him talk about feed. He kept on talking about food. It can be, he was trying to analyze it, whether it can be safer for food. Because I'm thinking the pills, I've been seeing them being fed, sometimes goats feed on them, even without you feeding them. So I don't know whether you only explored the chemical components of this, but what about the utilization in livestock? I didn't hear about that. You will answer it later. Because I know most of livestock feed on banana peels, all types of potatoes, including the sweet potatoes, but I didn't understand exactly why you did not mention about feed. You kept on talking about food. The other one is on for Hassan, a good area in Baobab. But you have talked about sites. What about the form in which the leaf is? I believe when the leaf is dry, it could actually have different concentrations of elements compared when the leaves are green, and irrespective of where the sites are. Thank you.
Okay, thank you. I have one for Ochwa. That is something on biostimulant. At first, he said that the research had been done for maize in a dry area, and it was positive. I face this other side. Okay. Okay, thank you. At first, he said that when he was presenting, that the first research was done and it was in a dry area and it was positive. What he didn't give us is how much water was there when it was positive. Now that he has used 413.6 millimeters, it is not significant. Can you also get a justification as why it's not significant? And this 413, is it annually, the irrigation, or monthly, or as for the whole season? Thank you.
Another question, especially for, again, Ninmana, if any. Any other question? Yes, Professor Mura there, or are you raising your hand? Please give him. Okay. Hamed, would you respond to the questions raised?
Ahmed, can you hear some sound?
We hear you, so proceed.
Okay, thank you. He asked about the dry matter and the freshness of the leaves. But actually, in terms of analysis, we are just considering the dry matter for all the parts of the baobab, such as like leaves and fruit bulb and seeds oils and dry matter, not in the freshness. So that's why we consider the dried one, and the differences could be belong to the differences sites or regions as I presented. Thank you very much.
Great. Oshua, would you respond to the questions raised to you?
Sure. Thank you so much, Chair. And thank you so much, person who raised the question. It's nice to get a very nice question like that. Yes, definitely the results were positive during the drought stress. Now it turns out to be not positive during irrigation or precision irrigation. The reason is simple. It's because, like any other treatment, by stimulants, first of all, by manufacture, why it was manufactured is that the main purpose was tailored to ameliorating drought effect. But Normally, the effect of biostimulants, according to literature, it shows that the effect of biostimulant depends on the severity of stress. So the higher the severity of stress, the more likely that you will register positive effect compared to when the stress is limited. So when the drought stress was limited because of precision irrigation, the effect of the biostimulant was not felt. That's why. So the effect cascades within the severity of drought. And then, yeah, that's the reason as why. Thank you.
Thanks. Agamini? Agamini Mana? Please respond. The T means what? Tasman. Respond to the question raised to you. Why not feed? I think that was a question.
Yes, thank you, Prof, for the question. Normally, potato peels, they have, when they are generated, they have an issue of the bitterness, which is due to glycoalkaloids. Some animals, they don't, it doesn't taste good. Some animals, they don't eat them. So we need to treat them like reducing that kind of chemicals. That's why I was focusing it for food safety, safely, because that glycoalkaloid is a key or a target for food application. That's why I was not, and I'm from food science, so because this is part of a PhD project, I want to apply this further for chips processing. That's why I was saying safety issues.
Thank you.
Yeah, thank you very much.
Online, is there a question for him?
Do you have any question online?
Do you have any question online? I don't see.
Oh, Charles. Charles.
Please read
oh.
it. Read it. Read it, and to who is it directed?
There's a question from Professor Kimurto. He says on microbes and maize, it's an interesting study, but was nitrogen analysis done on tissues so that you could be able to correlate the photosynthesis and explain the yield increase obtained? So was there an analysis from the presenter from the bacillus? I think so.
Oshua.
Oshua, please.
Oshua, are you still there?
Yes.
You heard the question?
Yes. Yeah, my answer is yes. We determined a lot of data was collected, including the concentration of different elements in the different parts of the maize plant, and including other parameters like biomass and the rest. The preliminary study, I could not put all the reasons within this presentation, but it could be also one of the justifications. But because I did not provide that data to validate that reason, that's why I could not mention it. But that's a very nice insight. I'll be in the next analysis. We are going to consider all those analyses and see where the correlation was there, and maybe probably it helped to account for some of the variations.
Thank you. We'll engage with you more. We shall proceed with the other presenters. Mutinda, you are doing it virtually or face-to-face?
I am virtual.
Please go on. You have exactly 7 minutes.
Okay, thank you, Prof. So my name is Victor Mutinda, and my co-authors are Professor Skingori and Professor Ambula from the Department of Animal Science. The topic is carcass characteristics and descriptive sensory quality of broiler chicken fed extruded sorghum meal and exogenous phytase-based diets. White meat such as chicken meat are considered beneficial in human nutrition because they have low fat, low cholesterol levels, high iron levels, and they can be sold in typically convenient portions. Their consumption also lacks religious restrictions, and therefore their demand is constantly rising. Therefore, it is necessary to increase the overall chicken production to meet the growing demand for chicken meat. The sustainability of broiler production depends on the supply of some limited energy and protein sources, namely maize and soybeans. Maize is the most commonly used energy cereal in broiler feeds, although it is staple food and it is demanded for biofuel production in developed countries. This poses severe competition and thus it increases its global market price. The search for alternative energy sources, therefore, is rising, and one such alternative is sorghum. Although sorghum can potentially replace maize in broiler feeds, some varieties contain anti-nutritional factors which, when included in broiler diets without mitigation, affects their performance. It is also known that the composition of diets, especially the energy sources, directly influence the broiler carcass characteristics and the sensory quality. The consumer's sensory perception of a food product affects preference, acceptability, and willingness to purchase the product. Although there is growing interest in the utilization of extruded sorghum meal and exogenous phytase enzyme in broiler diets, very little is known about the effect on broiler carcass characteristics and sensory quality. Therefore, this study determined the effect of inclusion levels of extruded sorghum meal with or without exogenous phytase enzyme in diets on broiler carcass characteristics and sensory quality. The study was approved by the Egerton University Research Ethics Committee and also the National Commission of Science and Technology of Kenya. It was conducted in Egerton University in the Tarton Agriculture Park and the Department of Dairy and Food Science and Technology. The experimental design was a 3x2 factorial arrangement in a completely randomized design, which was used to determine the effect of extruded sorghum meal at 3 inclusion levels, that is 0, 50, and 100% in diet with or without exogenous phytase, that is 0 and 0.035% for the enzyme. There were 6 dietary treatments. Treatment 1, which was 0% extruded sorghum meal without phytase. Treatment 2, which was 0% extruded sorghum meal with phytase. Treatment 3 was 50% extruded sorghum meal without phytase. Treatment 4 was 50% extruded sorghum meal with phytase. Treatment 5 was 100% extruded sorghum meal without phytase, and treatment 6 was 100% extruded sorghum meal with phytase. Each treatment was replicated 3 times, and each replicate comprised of 6 mixed-sex COM500-day-old broiler chicks. The statistical model used was as follows: Yijk, which is observation K in level I of extruded sorghum meal, and level J of phytase, mu, which is the overall mean, A of I, which is the effect of level I of extruded sorghum meal, and B of J, which is effect of level J of phytase. AB of Ij is the effect of interaction of level I of extruded sorghum meal with level J of the phytase, and mu is the random error. Management of birds: a total of 108 healthy mixed-sex day-old commercial broiler chicks were purchased from a local commercial hatchery and fed a standard maize soybean diet for the first 48 hours while acclimatizing to the experimental conditions. On the 3rd day, chicks were weighed in groups of 6 and randomly allocated into 18 deep litter cages measuring 1 square meter, and the chicks in each cage were randomly assigned to one of the 6 diets with 3 replicates. The grower and the finisher diets were offered from day 1 to 21 and 22 to 42 respectively. All broilers were weighed after day 42 to obtain slaughter weight, and 3 per treatment were sampled. The broilers were stuffed for 8 to 10 hours with free access to water before slaughter. The slaughter process involved stunning and severing the jugular vein and then allowing blood to drain for 5 minutes. The slaughtered birds were scalded in hot water about 50 degrees Celsius for 1 minute to allow for plucking of feathers and manual evisceration. The carcasses were undressed by removing the neck and the shank, and the hot dressed weight was recorded. They were chilled at 4 degrees Celsius for 24 hours and reweighed to obtain the cold carcass weight. The dressing percentage was expressed as hot dress weight divided by the weight of a live chicken. The wings, breast, drumsticks, thigh, abdominal fat, and internal organs, that is liver, heart, and gizzard, were removed and weighed in grams using a 5 kg generic digital weighing scale with 1 gram accuracy. The length of the small and large intestine were measured in centimeters using a Taylor's flexible measuring tape. The weight of various organs were expressed as a percentage of the live weight. Descriptive sensory evaluation. A total of 10 to 12 experienced semi-trained panelists aged 25 to 40 years were recruited for descriptive sensory analysis for 3 days as recommended by the sensory spectrum. The panelists were previously screened and trained for 1 day before being selected to participate in the descriptive sensory evaluation as recommended by the ISO guidelines. The panelists were trained to develop sensory descriptors and define sensory attributes related to texture, flavor, juiciness, and appearance of broiler meat. They agreed on definitions, references, and intensities used during the evaluation. The panelists evaluated various attributes on both the quantitative descriptive analysis scale and the just about right scale. Initial hardness, cohesiveness, and moisture release were determined in the first bite, while the hardness of mass, cohesiveness of mass, fibrousness, chewiness were determined in the chew down stage. A 9-point hedonic scale was used for descriptive sensory analysis of the broiler meat, while the just about right scale was used to evaluate the appropriateness of color, texture, tenderness, juiciness, taste, flavor, and overall acceptability. The just about right scale indicates the reaction of consumers towards a specific attribute and can be used for diagnostics and explanation if the overall product appeal is lacking. Skinless breast muscle used in the determination of carcass characteristics were thoroughly washed with clean water for sensory evaluation. Each sample was boiled in a different pot for 45 to 60 minutes at 100 degrees Celsius without adding any spice or salt. The samples were then deboiled manually, cut into cubes of approximately 2 centimeters cubed, and wrapped in aluminum foil to maintain warm temperature. Each panelist was then presented with 6 pieces, that is the 6 dietary treatments, every day for 3 days on a white sensory evaluation plate labeled with the 3-digit blinding codes in a completely randomized design. The panelists were provided with warm water and biscuits to cleanse their palates between each sample evaluation. The sensory evaluation room was organized according to the recommendations of Lawless and Heyman 2010. Data was subjected to a 2-way analysis of variance in a completely randomized design using the general linear model procedure of a SAS. The mean separation was done using Tukey's honestly significant difference test at a level of significance of 0.05.
Tinda, listen to me.
Yes?
You have exactly 2 minutes, which is
okay.
Extra.
Okay. So these are the results, they are tabulated. So the main results were that the inclusion of extruded sorghum meal above 50% in the diets reduced slaughter, hot carcass, and cold carcass weight, abdominal fat, and the weight of the gizzard. It also increased the scores for aroma intensity and the sustained impression of juiciness, chewiness, and flavor, while it reduced the scores for white color intensity. All sensory attributes analyzed using the just about right scale were just about right. In conclusion, inclusion of extruded sorghum meal up to 50% and the incorporation of exogenous phytase enzyme did not affect broiler carcass characteristics, the internal and external parts, other than descriptive sensory quality. Extruded sorghum meal, in conclusion, extruded sorghum meal with exogenous phytase enzyme can replace up to 50% of maize in broiler diets without adversely affecting broiler carcass characteristics or descriptive sensory quality. I would like to acknowledge first the Almighty God for His providence and allowing me to complete this study. I acknowledge Egerton University through the Department of Animal Sciences, the Department of Dairy and Food Science and Technology, and also the Tartan Agriculture Park. Lastly, I acknowledge my supervisors for their technical input and supervising this work. Thank you for listening.
Thank you, Mutinda, but please stay there. We'll come to you in a few minutes back. Please give a clap to Mutinda. He's telling you how to manipulate the broiler meat nutritionally. Do we have Masai? Masai, you are doing it physically. Please come. We'll want Muhindo to also be ready. You will follow immediately after Masai. And Bundi, also prepare. We'll have you make a presentation in a few minutes. Masai, proceed.
Thank you. Good afternoon, all. My name is Haron Juma Masai. I'm presenting on the performance of honeybees supplemented with soybean, chickpea, and Prosopis juliflora pods-based diets. My co-authors are Professor Anthony Kingori and Professor Mary Ambula. We are trying to check on a diet to assist the bee during the extreme drought. That period means that time when bees are not able to access nectar and pollen. The presentation outline is as follows. I will start from introduction all the way to acknowledgement. In my introduction, beekeeping contributes to poverty reduction, food security, employment, and income generation in arid areas of Kenya. And as you can see, our landmass is composed of over 80% of the arid and semi-arid, and therefore there is need to be keen on the issue of beekeeping. Globally, China is the leading producer of honey with over 500,000 tons of honey per year. In Africa here, Ethiopia is the leading with over 45,000 tons of honey and processed honey annually. And in Kenya, we have a capacity to produce over 100,000 tons of honey. However, we are only able to exploit 20% of our prospect. In sub-Saharan Africa, we depend majorly on naturally occurring plants to produce nectar and pollen to the honeybee. However, with the issue of climate change, this is making it difficult for the bees to find forage. And as you can go through studies, improved nutrition has proven to increase the population of the honeybees, and as a result of accessing quality pollen and nectar, which fosters the reproductive quality of the honeybee. A certain reduction in the amount of pollen during the brooding period of the bee will definitely reduce the population of the honeybee. And therefore, there is a need to have a supplemental feeding to ensure that the bee survives during the time of need. This study therefore focuses on investigating locally available feed resources that could be used as pollen supplements during time of drought. Those are some of our ingredients that we used in our study. This study was carried out in 2 sessions. Lab analysis was done at Egerton University Animal Science Lab, and feed trial was done at Dryland Research Training and Ecotourism Center in Chemeron, Baringo County. That is the map of the study area. The experimental bee colonies were sourced from practicing beekeepers in Nakuru County, that is Naivasha, Uasin Gishu, that's in Eldoret, and Kitui County. And then they were transported and maintained in Chemeron for a period of 1 month before they were started on feeding trial. They used the type of hive that was used was Langstroth, and these bees were housed in a grass-thatched wooden house because of the temperatures in that region. Prosopis chiliflora pods were collected from Kalro, a beery center in Marigat, then were brought here for processing. The feed formulation in this case was by use of linear programming as a least cost method. The selected ingredients were available both in the local market and as, in the retail shops. Samples were prepared according to the table 1, which will be shown. In our formulation, honey was incorporated as a binder, sweetener, and a moisturizer, which was aimed at increasing the palatability to the bee, because it's their product and they feed on honey, and also to extend the lifespan of the feed before we replace. Table 1 shows the composition of the diets, as you can see. Then there's another table, feed formulation comparative analysis. We were doing with the linear programming, then we compare with what we were getting from the lab. That's, we have table 2 for diet T2, which is soybean, table 3 for diet T3, which was chickpea, and table 4, comparative analysis for diet T4, which was use of Prosopis chiliflora pods. Each group of these experimental colonies was given sugar syrup for a period of 1 month. Then they were introduced to the diet. T1 control was not given any supplement after the 1 month. Then T2 was offered soybean meal. Then T3 chickpea, T4 Prosopis chiliflora. We measured 250 grams for each using the top bar technique. We use smoker and brush to make sure that we drive bees before we place the pollen patties. Measuring the parameters, colony development, we use the grid frame to measure the sealed brood area at an interval of 2 weeks. Then bee population we checked at every 4 weeks, and honey yield was harvested at the end of the experiment. The honey bee population was estimated at 28 days by observing the number of frames covered by bees. And the model used is displayed there, you can see. That graph shows the result for. One of the objectives was to check the acceptability of this diet to the bee, because we were introducing a new diet and they are used to natural flora. So you were able to check and see whether they can accept our diet. So as you can see, there was acceptance for T2 and T3, which was higher than for T4. Then the brood area, you can see from the graph, T2, T3 gave the highest brood area, and T4 was also fair as compared to T1, which was not fed on any diet. The number of frames covered by bees, the same trend continues. T2, T3 gave the highest, and T4 was fairly compared to controlled diet. Honey yield was higher in T2, followed by T3, and then by T4. Then the lowest was T1, which was not fed on any diet. Bee colonies fed on chickpea and soybean-based diet had the highest sealed brood area compared to those fed on Prosopis and the controlled colonies. This could be due to higher protein availability in the two ingredients. The consumption of diet, in this case, when in July, when rain started, then this other natural flora started reappearing, and the flowering season started. Then the consumption of our diet started decreasing. This displays that the preference for the bee is the first preference is on the natural flora, which gives quality nectar and pollen. Similar results were reported by researchers like Kumari and Kumar, who recorded decline in diet consumption after the onset of monsoon season due to the availability of natural flora. From what we've seen from the graphs, the feeding itself improved the colony performance compared to the control colonies which were not given any diet. This is an important for the maintenance and colony build-up during the extreme diet period, that extreme time when there is nothing completely for the honeybee. The ISB population was recorded in colonies fed on soybean and chickpea compared to colonies fed on prosopis and the control. The results are consistent to the other researchers who conducted the same results. They are consistent that when you feed higher protein diet, you stimulate the colony to grow. And therefore, a robust colony is better equipped to efficiently collect nectar, produce honey, and defend against diseases. In conclusion, this study found that chickpea-based diets and soybean-based diets provide a significant improvement in performance in colony development, number of frames covered by bees, sealed brood area, and honey production. And in our recommendation, we recommend that further studies should concentrate on other feed ingredients from different regions that can be used locally to supplement the honeybees, because sometimes you might not find sorghum or soybean in all the regions, but there are other diets that we can take to the lab and find their nutritive value and be used to feed the honeybees. Again, we recommended that we need to adapt such kind of drought-resistant plants like cactus, which can survive the drought and still provide pollen and nectar to the bee. Because this one, we were walking through Baringo, and we found this kind of cactus flowering, and it was so nice to the bee. I would like to acknowledge the Department of Animal Science, Egerton University, for their support and their providing the conducive environment for this study, and also the Dryland Research Institute in Baringo for their support throughout the period of my study. Special thanks to TAGDEF program for their financial support. Thank you.
Thank you, Masai. If you need honey, talk to Masai. You'll also protect you from the bees. He's finding alternative feed. You'll engage him during his time. Shall we now have Muhindo before we field questions? Muhindo, please.
Good afternoon. My name is Muhindo Daniel. I want to present the preliminary result of my ongoing research on rice response to rice husk biochar, mineral fertilizer, and watering regimes. So I've been supervised by Professor Samuel Mwonga and Professor Joyce Lele Indemo. Thank you. So quickly, because we do not have time, two features with rice is that one, it really consumes a lot of water. To produce 1 kilo of rice, you need 3,000 to 5,000 liters of irrigation water, which is 2 to 3 times more than other cereals like maize and wheat. So seeing that there is a shortage of water all over the world, and specifically in the region where I conducted this study, we need to come up with ways of producing rice with limited irrigation. Another fact with rice is that nutrient use efficiency under rice cultivation is generally very low. And the nitrogen, which is the most important nutrient for rice production, is lost in the soil through different mechanisms, including surface runoff, leaching, volatilization, and denitrification. So considering that, we also need to come up with strategies to control N losses in rice fields. And when I was digging into the literature, I came up with these two interesting practices: biochar application and alternate wetting and drying irrigation, which can ensure sustainable rice production by increasing the nutrient use efficiency under rice field, the carbon sequestration, the yield, the water productivity, which is really causing a problem, while reducing the gas emissions. So the broad objective of this study is to contribute to the improved food security and adaptation to climate change by sustainably increasing paddy rice yield through biochar and mineral fertilizer application, but also under efficient paddy rice watering regimes in my region in South Kivu in DRC. Specifically for this presentation, we want to determine the effect of biochar, NPK fertilizer, and watering regimes on paddy rice yield and nutrient uptake. So this study was conducted in the Ruzizi Plain, which is a vast lowland area shared between DRC, Rwanda, and Urundi. And the DRC part is covering 8,000 hectares. And I selected 3 rice-producing areas where I conducted this study. So in the 3 sites, I installed a factorial experiment in a split plot arrangement, whereby the watering regimes, I don't know whether the figure is clear, consisted of 2 water management, permanent flooding, and alternate wetting and drying. We also had 2 cultivars that we considered as the subplot, and finally fertilizer treatment with 6 levels, the negative control where we didn't apply any fertilizer. We used 2 types of biochar, the rice husk biochar and the manure charge biochar, whereby we were mixing manure and rice husk biochar. Then we had our positive control, which is the mineral fertilizer. And then we combine this mineral fertilizer with the 2 types of biochar, rice husk and the manure charge. And the biochar was applied at 5 tons per hectare, and the mineral fertilizers, you can see the figures. So when it comes to fertilizer application, the biochar, the full rate of biochar was applied 2 weeks before transplanting, while the mineral fertilizer, when it comes to urea, was splitted. Half of it was applied at the time of transplanting, 25% at tillering, and 25% at panicle initiation stage. But when it comes to phosphorus and potassium, they were all applied during transplanting. As for water management, the application of alternate wetting and drying started 2 weeks after transplanting. And in the plots where this practice was applied, we installed perforated tubes that helped us to monitor water depth And in these plots, we were reapplying water whenever the level of water was dropping 15 centimeter below the ground level, as you can see on those figures. And because this is just our preliminary result, we used the freeway ANOVA to analyze our data in R, and the mean separation was done using Taki test at 0.05 level of significant. So our preliminary results are quite promising because we found that the fertilizer treatment significantly influenced paddy rice yield and nitrogen uptake compared to NPK, which is our positive control, and the control, the unfertilized control. The combination of NPK and the first type of biochar respectively increased yield by 27% and 161% in Luberizi, 15% and 52% in Kiringi, while the other type of biochar combined to mineral fertilizer increased yield by 11.68% and 62% in Luberica. So similar trends were obtained when it came to nitrogen uptake. Now, considering the second factor, watering regimes, we discovered that alternate wetting and drying had a similar yield compared to permanent flooding. And this is already a very interesting result for us because under alternate wetting and drying, we use less water compared to permanent flooding, but we are getting similar yield. This is really crucial, especially in my region where farmers are getting into conflict because of access to water. And in addition, this practice, alternate wetting and drying, increased the nitrogen uptake in the free sites where the study was conducted. But as for cultivar, there was no difference between the two types of cultivars used, apart from the nitrogen uptake, which was higher for the Thai cultivar because it has high biomass, so it pumps more nitrogen into the soil. So quickly, as a take-home message, we think that the combined application of NPK and biochar, as well as the use of alternate wetting and drying irrigation, are really promising climate-smart strategies for boosting paddy rice production in the Ruzizi Plain region, where soils are really poor because they are sandy soils, and access to water is becoming increasingly difficult and frequently leads to farmer conflicts. Second, the use of rice husk biochar represents a potential alternative for paddy rice residue management because up to now these residues are just burned. So if we can value them by converting them into biochar, this is really important for the region. However, we recognize that extensive research is necessary to determine the optimal frequency of biochar reapplication because biochar is not meant to be applied every season. We need to determine after how many seasons we need to reapply biochar in the field. So I really couldn't do this work without the help of this mom who helped me to produce biochar locally, the help of this student of our university, the Catholic University of Bukavu in DRC, who helped me to collect the data because collecting rice data is really not easy. 1,000 thanks to my incredible supervisors, Prof. Samuel Mwonga and Prof. Joyce Lele Ndemo. Of course, I thank Egerton University, my university, and Africa Uninet, as well as Ruforum, which funded this research. Thanks a lot.
Great, great. So you can produce rice now with less water. Great. Now, shall we have a discussion with these gentlemen, starting with Mutinda, Masai, and then Muhindo, before we have two more presenters remaining. Any question to Mutinda? Mutinda, are you there? Mutinda? You promised.
Yes, Prof.
Good. Listen.
I can hear you.
Listen to questions now that are directed to you from the audience. Any question to Mutinda? Please provide the microphone there.
Thank you. Thank you, Mutinda, for a nice presentation. I just wanted a clarification from Mutinda, particularly on the sensory one, where he's actually identify some people who have, I don't know, 25 years and what, 40 who are going to test. Is it the chicken or something like that?
Broiler meat.
Broiler meat. I wanted to know whether how did he select these people, because I know, are they similar, those who are testing? Because it's possible.
Similar in what?
I want to give you the example. Mutinda should hear that. If you pick people, 2, 3 people, one is a drunkard, drinks a lot of alcohol, and the other one doesn't drink, their taste buds are completely different. And so, did he really check these people? And also, if they have the same health status, because health also affects your taste buds. So that's what I wanted to find from him. And then the last one is for Masai. Masai is talking about bee colonies. I like what he's doing. But this bee that were being fed on, what was it? Soybean. And there are different colonies. How far were they from one another, these colonies? Because it's possible bees move from one colony to another and to establish even new colonies. And they might have actually carried the food from this colony to another one, and therefore affecting the controls or the other, whatever was being fed to the others. How did he control for such situations occurring? I know it's not easy, but what did he think about it?
He'll tell you, that's good.
Thank you.
Other questions? Yes?
Okay, thank you. This goes
Please note those questions so that you'll answer them.
This goes to Mutinda. I just wanted to find out, he wants to replace maize with...
Mutinda, are you listening?
With sorghum.
Mutinda?
Yes, I am listening.
Okay.
Yeah, I wanted to find out, the sorghum you used, was it the sorghum that contained the tannins or not? That is from Mutinda. Then for Masai, he said that the bees, there were some which were moved from, I don't know, was Ngishu, and then others from Kitui.
Including Naivasha.
Yeah. What I know is that the movement of the bees to Marigat, to a totally new area, doesn't that affect their performance? And yet you are going to carry out the experiments on them. And then secondly, what is the mineral supplement, or which supplement is normally used originally before you went to introduce this, so that we can be able to peg the supplement that was being used before vis-a-vis what you are introducing now in terms of their consumption.
Beautiful, beautiful.
Then lastly, Muhindo.
Muhindo.
Yeah, you are doing something on nitrogen uptake. Now you are using NPK. Did you top dress your crops? And if you did top dress your crops, at what stage did you do the nitrogen uptake? And why not phosphorus uptake? Thank you.
Beautiful. Other questions to these three presenters? Other questions from the audience? Yes, give the lady there.
My question goes to Masai on feeding with soybean and chickpea. Can he tell us the quality or the taste of the honey the final product compared to the natural nester.
One more last, if any.
There's no more question, I think so.
Then we proceed. I'll start with Muhindo. I think you're the only one. Muhindo.
Thank you, is it Prof or Doctor, for the question. Did I top dress? Nitrogen, yes, because I explained that half of the quantity which was planned was applied at transplanting, at the time of transplanting, 25% at tillering stage, and 25% at panicle initiation stage. And those stages are really very crucial for rice production. Why not P? Why nitrogen? I think I didn't have a lot of time to elaborate in my introduction, but you may know that nitrogen is the most important nutrient for cereals and particularly rice, and unfortunately this element is lost into the soil food through different mechanisms, and I explained them: surface runoff, leaching, volatilization, and so on. Compared to phosphorus, nitrogen is labile in the soil. This is why we focus our research on nitrogen, because this biochar that we are applying in the soil has really a good potential of stabilizing nitrogen in the soil. I can't deny that other aspects are really purely financial, because if you want to focus on phosphorus as well, you need more samples, you need more money to analyze the data, and the money was not available. Thank you.
I hope you're not making an excuse. Masai, you had several questions.
Thank you very much, Chair. First, I want to address the question asked by Professor George concerning the movement of bees from one hive to the other. In this case, we were using the top-bar feeding technique, which means our diet is placed in individual hive, the feed is put inside the hive, and as we can learn from the bees, they have different roles. Honeybees have bees who play a role of guarding the colony at the entrance. We call them guard bees. So they make sure that there is no robbing happening within. So there were no bees coming from the other hive taking the soybean from the treatment colonies on soybean or a chickpea or prosopis, because the guard bees were taking care of that. So that's a good question, and I think it's well answered. And again, there is this question of movement of bees from Kitui.
Different counties.
Yeah. Mm-hmm. Initially, I needed to work with bees from Baringo County, but there was a challenge. Most of the beekeepers in Baringo County are using log hive. And you can, from what I needed to measure the parameters. Log hive, it's very impossible to measure those parameters that I was checking on. So I needed Langstroth hives so that it can make easy for myself to manipulate the frames and check on those parameters. So what happened?
So you brought the hives, or you brought the bees?
The bees. You see, I could not bring the bees from the log hive, then transfer to the Langstroth, and still manage to maintain them. It could take a long time. So I needed to get ready bees with the hives. So I brought the bees inside the Langstroth hives. I tried to move around to Calro. They had Langstroth, but then they were not able to sustain their colonies because of the higher temperatures. So when I started my experiment, I found some bees in Kitui. So I considered the Kitui ones because it was the same temperatures with Baringo. But when I brought in January, it was very hot and there was extremely nothing to feed. And at that time, I was feeding on sugar syrup. And that sugar syrup could not be able to sustain the colonies. So I decided to go to Naivasha. I got some colonies, which were not enough. Then I got a farmer whom I had assisted when I was working in Eldoret. He had some colonies I bought from there. Then I brought for a period of 1 month. That's why I'm insisting on the 1 month to acclimatize these colonies to this new environment. So the feeding trial started after 1 month of acclimatization. And there's another question of mineral supplements that were originally offered to the bees. If you ask anybody, even from here, they will tell you that when there are no flowers, we give the bees sugar syrup and water. But the content in sugar syrup, there's no protein in sugar syrup. And for bees to continue brooding, they need at least 20% crude protein levels to make sure that they are able to sustain, and a good balance of amino acid. So our aim was to check whether we can introduce high protein diets to the bee and check whether they can perform well, better than the sugar syrup. The sugar syrup is only intended to sustain the bees, to give them energy to fly and find forage. Then there's this question on quality and taste of honey compared to the natural pollen. The honey that we are getting from these bees is coming from natural pollen, natural nectar. Because I said that our intention was to make sure that we raise strong colonies during the time of that, and in that period there is no flowers. So it means we have to feed these bees to sustain them, so that when the flowering season begins, we have large number of bees taking advantage of the flowers and going to bring nectar to the hive. So our intention was to make sure that we don't suppress the colonies during that period, but we increase their numbers so that they take advantage of the honey flow period. So the honey is purely coming from the natural nectar. Thank you.
You have left one question. Were the colonies closer or far?
They were closer. They were in a small hut.
Explain to them how you transported the colonies.
We transported the colonies from, we used the dairy science car that's used for yogurt. We put the colonies there in that that van, that pickup. At night, we transported at night because we could go there in the evening. Then we packaged the colonies in the boxes. Then we could travel throughout the night. We reached Baringo, then we moved to the house. That was basically what we did.
Thanks, Masai, for going to that length. Any question for Mutinda? Is there any? Mutinda? There was a question from Joyce.
Yes. Yes, there were two questions.
Yes.
Let me answer the first one about the issue of the age of the panelists that I used.
Yes.
The range between 25 and 45, and that was before panelist screening. During screening, I was able to remove the ones who did not have the ability to differentiate between the sensory attributes. I used affective tests and acuity tests, such as the triangle test, after which I settled on a few who were able to differentiate between the various sensory attributes. Then on the second question about the type of sorghum that I used type 3 sorghum, which usually contains high tannins, which has benefits such as resistance to depredation by birds in the fields. It's also resistant to mold attack and weeds, and it is also more drought resistant, and it does not face competition in utilization because it is not used for brewing like the other low tannins varieties. Thank you.
Thank you, Mutinda. Thank you all. Please give a clap to all of them. I don't know if you have 2 or 3 presenters. I'm getting conflicting reports. I'll go with the 2 that I've confirmed. There is Ubundu. Ubundu, are you there? Is Ubundu there?
Yes, I'm there.
Oh, you are online.
Yes, I'm there.
And you're presenting from where?
I'm presenting online. Huh?
Yes. From which location?
Yeah. Okay.
Do you have your slides?
Yes. Just a minute.
But also declare where you are. Declare your location, Ubundu.
I am presenting from Siaya.
Okay, go on.
Yes.
So you're a Kenyan?
I am a Kenyan.
Good.
Thank you.
Trouble? We don't see the slides yet. Is there a way we can help?
I'm trying to connect to my laptop. I can't be able to present through the phone. Maybe you can give the next presenter a chance as I prepare.
Okay, prepare. So
Yeah.
we'll call you back. So shall we have Bundi? Bundi, is your presentation ready? Then come over, please. Organizers, there are 2 names. Please confirm what decision you are making over them. There are 2 names on the chart. Check. You have 7 minutes, exactly.
Good evening, Quorum. Okay, I'm Dr. Bundi, and my co-researchers are Dr. Agnes Oyoyo Nkuruma and Dr. Catherine Munyo. Sasa mkono yangu itafanya kazi yote. So I'm talking about influence of a shared learning platform on seed potato multiplication by smallholder farmers. My research I did from Kamara Ward, which is in Kurzoi North Sub-County of Nakuru County, Kenya. In Kenya, currently, formerly we used to have some large-scale farmers, but today, majority of our farmers are small-scale or smallholder farmers, and they own land less than 5 acres. I'm talking about potato production, and we start from provision of seed for potato production. Worldwide, potato is like a third staple food from wheat and rice and potato. In Kenya, it is the fourth staple food. That is, we have maize, we have wheat, we have rice, and then it comes fourth. Now, farmers are producing potatoes, but yet we are not meeting the quantity that we require for food. And this occurs not only in Kenya, but even in sub-Saharan Africa. You find that the population, most of them depend on agricultural sector for food and for livelihoods. In this study, we are using a shared learning platform so that we can be able to even make smallholder farmers to participate in production of seed potato for further potato production. And the platform is assumed that, and actually it's not just assumption, but it's that people or farmers on their own, they cannot be able to adapt new technologies which are being produced by scientists like you around on their own. So in that case, they may require the scientists who are producing the technologies to interact with them. It's not easy to do that, and that's why we are using a shared learning platform. A platform, this is where you bring several stakeholders together. They learn together as they share, and also sharing knowledge as well as sharing experiences. Smallholder farmers in Nakuru, they're the main producers of potatoes for consumption and also for their incomes. However, they are not participating in seed potato multiplication. That is one of the stages in the seed potato value chain where they could join in and then produce. Problems being that their farms are too small for that, and it cannot be allowed by KPs, that is the regulatory body for seed in Kenya. And also, it's possible that they may not be able to have the knowledge required. My conceptual framework consisted the situation analysis and what is happening on the ground, so that we could be able to come up with the problem, that's identifying the problem, and then also try to come up with the solution. This is where you have to involve the farmers or the people and the researchers, so that together they identify the problem, and then also together they find the solutions. So our aim was also to include the farmers in seed multiplication so that we can have enough seed. As I've said, the problem is that they are not allowed to produce seed for their farms, and yet that the people who are really consuming that seed, which is produced by a few bodies in Kenya, large-scale farms, and also some cooperatives. So with that, we started by doing a baseline survey. A baseline survey, we do it so that we can be able to identify the problem. And in participation action research, we do both, the researchers together with the other stakeholders, so that we can be able to identify the problem. We also share together to be able to find the solution. 120 farmers were randomly selected to participate in the baseline survey, which we analyzed later on, and found out that the problem the farmers were facing were, one, their farms were small, that they could not be able to produce seed. 2, they lacked knowledge and skills that are required in sweet potato production. So we had to involve both quantitative and qualitative research to be able to come up with the problems as well as coming up with their solutions. We used a questionnaire for the baseline, and also we used the same questionnaire at the end line after we have gone through the shared learning platform, so that now we could assess the situation later. We also used the key informant interviews for the key informant to give us more information about the farmers. And we used the focus group discussions to give us the qualitative research so that we can be able to know exactly what individual farmers are facing and if there has been a change. So with that, after having done that, we had both the data, that is qualitative and quantitative. So we had to take them through statistical, some were like descriptive, we used the qualitative, but for quantitative, we applied other statistical analysis like chi-square and linear regression. So after conducting that, the shared learning platform, maybe it is, this is where you bring on board all those people involved in the activity. Like in this case, we are looking at the sweet potato value chain. So that involves right from the laboratory, where they're using mint tubers, producing mint tubers, and even the mother plants, up to the early generation stage. This is now where you can take it out of the laboratory, and currently it's only the large-scale farmers who are allowed to do that. Then they can multiply it up to 3 generations, then they give to the farmers for planting. This is where we could include the small-scale farmers. So now that the problem was their farms were so small, on the platform, they were taught how to form groups, and now they were working as groups, farmer groups. So that means now we were able to get more than 5 acres, which is a requirement by KBIS. Number 2, they also needed to be taught on the knowledge that is required in seed production, seed potato production. And this one, the researcher who was me, I collaborated with the extension officers who had to undergo a training for 1 week so that they could go teach the farmers. So on the shared learning platform, the primary actors were the farmers and also the extension workers and other cooperation like ADC, who later on we shall see how they came in. So at the end of it, after they have learned and after they have been able to form groups, it was possible now to meet what is required. But as we were doing that, the study revealed that when people are learning by doing and they reflect, it becomes easy for them to adopt the skills and the knowledge they have learned. We also found out that as we were still on the shared learning platform, that it was very important that knowledge sharing. You know, the farmers, they are not just like a blank blackboard that you are going to write on. They also have their indigenous knowledge, which the researchers could also adopt and incorporate with the researched knowledge. So it's like a mixture of indigenous and the new knowledge that has been invented, so that it can be shared with the farmers and they can also participate in seed potato multiplication. We also realized that on the process, then, I've already mentioned this, we mixed modern knowledge and indigenous knowledge to be able to come up with, with what we require. So in conclusion, we found out that the determinants for farmers to be able to participate in the seed potato multiplication, we required a shared learning platform that is which is functional, where you have all the stakeholders participating, and specifically the primary actors were the farmers, because they're the ones who are being capacity built. They were the ones who were to mobilize the resources like land, and again, they're the ones who are getting the knowledge that is required and implementing. So at the end of the program, with 10 farmers were able to donate 1 acre each, so that they could also be allowed to produce seed. And then from there we would see that actually the research was not just getting knowledge, it was also creating change. With that, we found also it was necessary to give some recommendations. Like for example, in working with the farmers, it requires centralized coordination for the small scale or small order farmers to participate in seed potato multiplication. And our main purpose was for availability of quality or certified seed. We also found out that there is a need for coordination, not just one department, but several of them, so that the farmers can also participate in seed potato multiplication. And it was also important that we should have a shared learning platform for us to be able to produce enough seed potato for farmers' seed potato production. With that, I say thank you for listening.
Wait there. There will be questions for you. How to produce quality potato seed in a farmers' platform, innovation platform. Obondo, are you now there and ready? Obondo, are you there now and ready?
Ready, Prof. I am ready.
Proceed.
Okay. Please, Dorcas, may you... Okay. Please, are you able to see my presentation?
Yes, go ahead. Go on, eh?
You are able to see my presentation?
Put it on presentation mode. Obondo.
Yes.
Put it on presentation mode. We can see your slides.
Okay. Thank you.
Beautiful.
That's okay?
7 minutes.
Okay, thank you. So, panel members, thank you for the opportunity. My name is Obondo Kevin Otieno. I was working on quality assessment of Lake Victoria water hyacinth composting systems under the supervision of Prof. Samuel Mwonga and Prof. Joyce Ndemo. So that is the outline of my presentation. So compost is one of the main sources of organic matter, which is the basis of soil fertility, and it can be carried out either through what is called vermicomposting, use of EM solution, and thermophilic composting. because of time, I will move quickly. So in most part of Kenya, especially in the Lake Victoria Basin, there is low fertility, which affect crop production. And use of chemical fertilizers to improve fertility has been low due to the high cost. And therefore, this call for need to use alternatives amendments such as compost. Research has shown that water hyacinth, which is an aquatic weed, can be used to prepare compost so that we can be able to reduce competition from other sources of raw materials which we can use for composting. That is why we chose water hyacinth as the raw material. So the general objective was to contribute towards soil fertility enhancement through the use of water hyacinth compost in the Victoria Basin. And the specific objective, one of them was to see the maturity period of water hyacinth compost as affected by the composting system which we used. And the second one was to determine the effect of that composting system was going to have on compost physiochemical and biological properties. So the hypothesis matches the specific objectives. So due to time, I will not go into detail. So that was the study site in Assemble Bay, Siaya, which is in Siaya County. And those are some of the geographical parameters. So those are the materials that we used. Water hyacinth, which was harvested from Lake Victoria. It was supplemented with animal manure. We also had building materials, a shade. Then for vermicompost, we used earthworm, which is referred to as redworm, the senior fatida. We also bought some EM solution for the EM composting purposes. We had a screen shifting mesh, which was used after harvesting as opposed to harvest handling the compost. And of course, watering cans and a hose pipe were used during the management of the composts. So the photo shows how water hyacinth was harvested in Assemble Bay and how it was transported in a CBO within Assemble Bay known as Alarieko. And normally they promote the use of wheelbarrows as transporting agents where manpower is involved. So after transporting it to the site, it was dried. So you can see the two plates. On the right side is a dry water hyacinth, and on the left side is dry water hyacinth, and on the right side it has been mixed with animal manure. So those were the treatments. We had the three composting systems as the treatments, where we were putting 100 kg of water hyacinth, supplementing with animal manure. So for vermicomposting, that is how it was laid in the field. That is the redworm I was talking about, scientifically known as a senior fatida. Then for thermophilic composting, that is how it was laid in the field. Then for EM composting, that is a pictorial representation. So after that, the samples of the three composting systems was taken to the lab to analyze the physiochemical and biological properties as shown in the table. So on the right side, we have the parameters which were analyzed. On the left side, the parameters which were analyzed. And on the right side, the procedure which was used or methods to analyze the parameters. So the data was subjected to normality test by Shapiro-Wilk procedure using the software, and the analysis of variance was arranged in RCBD, and that is the model that was used, and the mean separation using the LSD, the least significant difference test. So on results and discussion, so our first result was on to see how the temperature was going to vary during composting. Remember, for thermophilic composting, high temperature is very important in ensuring that weeds and those toxic compounds or elements are inactivated. So it was high in thermophilic composting, where we are relying on organisms in the natural settings, and also in EM composting, the temperature rose up to almost 60 degrees Celsius. But for vermicomposting, the temperature remained almost near the ambient, simply because in vermicomposting, we are using those organisms which require relatively cold environment to be able to perform the activity. So those were the 3 different types of compost prepared from the 3 different systems. So we start with the left side, we had vermicompost, then we have thermophilic, then we had the EM. So this is a mature compost, and that is the color or the appearance. So looking on the first objective, which was to see how the system were going to affect the period it takes for the compost to mature, we found that with EM composting system that is using an effective microorganism, the maturity was very fast. Less than 50 days, we had our compost ready to apply in the field. This was followed by vermicompost and lately thermophilic compost. So on the physiochemical parameters, so the pH, there was relatively a significant difference with a high pH being recorded under EM, followed by thermophilic, relatively low in vermicompost. For the electrical conductivity, it was within the threshold level. For water holding capacity was highest in vermicompost, followed by thermophilic and EM. For bulk density, which is very important in terms of looking at the organic matter content, it was relatively constant. There was no significant difference. Then when checking on organic carbon, which affect the carbon to nitrogen ratio, again, this was significantly different. Then total nitrogen, which is a very important soil fertility parameter, was high in vermicompost, followed by thermophilic and then EM compost. Though thermophilic and EM compost, it was almost the same. Checking on LSD. Then for phosphorus, it was high again in vermicompost. For potassium, again high in vermicompost, but this was not different from the rest. It was not significantly different from the rest. Then for calcium, again, relatively high in vermicompost. Magnesium, high in EM compost. And micronutrients were relatively high in EM compost compared to the rest of the treatment. We also went ahead to look at how the composting system was going to affect microbial abundance, and we checked on colony forming unit for bacteria and fungi, and we found it was high in the vermicompost, followed by EM compost. But when we look at fungi, it was high, relatively higher in EM compost compared to the rest because of the presence of fermenting fungi in the EM compost solution, an EM solution which is used to prepare the compost. So also to check whether the compost, because it is coming from water hyacinth, which absorbs some element from water, and we know that water can contain some effluent, so we need to ensure that the compost we're preparing is safe for use. So we did a phytotoxicity test using what is more referred to as germination assay, and all the composts were found to be safe for use, as shown by the germination index, which was relatively above 100. Yeah, so that is my presentation. So from this result, we were able to come up with a suitable composting method for high quality water hyacinth compost. And this was vermicompost based on the parameters we analyzed. And this research has also been shared in early career research fellowship, which was conducted in Laikipia, and now in the 15th Egerton Biennial Conference, and we purpose to publish it in peer review journal. So on acknowledgement, I would like to thank the Center of Excellence for Sustainable Agriculture and Agribusiness Management, that is CISAM, for sponsoring my master's studies, the Egerton fraternity, the Delaria for CBO, and of course my supervisors for the excellent technical support they offered me. So thank you very much for listening.
Thank you, Bondo. Where do you do those mineral analysis?
They were done at NAL. Some were done at NAL, Nairobi, and others at Egerton Soil Science Lab.
Thank you. Please stay on. We'll come back to you with some questions from the audience.
Okay.
We have a last presenter online called Amuge. Amuge, are you there? Amuge?
Yes.
proceed. You have only 6 minutes. I have no title of what you are presenting, but proceed. Supporter Muge to have his presentation. Yes? Click it.
Yes, I've loaded it.
Yes, but click that. Oh, yeah, good. Proceed.
Thank you, Prof. My name is Michael Amuge, also known as Lochampa. I'm presenting this work, which I did with Dr. Mwasia and Lashia and Dr. Ngeno. Mwasia is from the Department of Animal Science. Lashia is from the Dairy Research Institute. And Ngeno was previously from the Department of Animal Science. The work is on single nucleotide polymorphisms in selected candidate genes and their association with body weight in Gallus domesticus. So single nucleotide polymorphisms are changes in nucleotide in the genome of any organism. Gallus domesticus are the local chicken. My introduction is short. I'll do a bit of introduction, then heroes and methods. I'll do the results, and I will finish with the conclusion. So on to my introduction. Chicken serves three value importance for the community, for the country, and for the environment. So in terms of egg production, meat, and also income, that serves the household and the country's interests. In terms of the communities, it also serves the cultural importance and also empowerment of women and people with disability and also youths. In terms of environmental importance, has a lot of importance in reducing deforestation, seed dispersal, and other integrated systems. So local chicken has high demand in terms of meat, which in most cases results in higher market prices. And among other factors, body weight determines higher market prices for the local chicken. So local chicken have always been degraded and touted as being poor producers of meat, and also have low slow growth rates and low mature body weight. So to alleviate the situation, cross-breeding programs have been started by government and other institutions working with communities. And the effect of these cross-breeding programs have reduced genetic diversity and also introduced genetic dilution within these communities. Body weight can be classified into three. We have small body weight, we have medium body weight, and large body weight. In terms of phenotypic variation, body weight can vary in terms of the age of the birds, in terms of the sex of the birds. When they are female and they are males, they have different body weights, and also in terms of the different types of birds, which in local chicken we normally call them ecotypes. So over the years, around 70 years period, body weight has increased from less than a kilo, to around 4 kilos in the 70-year period. So genetically, body weight is a quantitative trait, which is determined by many genes, many genotypes, and many chromosomes. So it shows phenotypic variation, the way I have shown in the previous slides, and improvements require genetic variation and effective methods to be able to realize genetic improvement. Body weight also shows moderate to high heritability of 0.28 to 0.64. And it's also highly correlated, positive correlation with carcass traits and growth rates. So candidate genes are unique to each domestic chicken population because they express themselves in different adaptations, different production systems, in different environment of reproduction, and also different environment of immunity. So to improve body weight of indigenous chicken, there is need to understand the genetic background of its expression. Association of BMPR, that is the bone morphogenetic receptor 1B, dopamine receptor D2, NPY, and melatonin 1C genes with body weight has been, the association of these genes with other traits have been established, but for body weight, there is little information that links these genes to the body weight of chicken. So the study objective was to identify the SNPs within these 4 genes and their association with body weight. The study animals were 234 indigenous chickens, assembled from 24 villages in 6 regions of Ethiopia. We had Afar, Amhara, Gumus, Oromia, and SSNPR, and Tigray. So the 234 chickens were 146 females and 88 male birds, varied in weight in their ages between 4 to 3 months, with an average of 10 to 3 months. The body weights were also varied, 0.6 to 2.6, and the phenotypically, the body weight was measured using a digital scale with a sensitivity of 1 gram. Blood was extracted from the wing web using syringes and cryotubes filled with absolute ethanol. Then the DNA was extracted. There was a long process, which I wouldn't really want to go because of time. DNA was extracted and concentrated using spectrophotometer, and the quality and the quantity was checked by agarose gel electrophoresis. And after extracting the DNA, it was sent to Edinburgh Genomics for whole genome sequencing. So at the laboratory in Edinburgh, the library was prepared and the control was done. The quality control was done using Illumina Sequelab specific TrueSet nano high throughput laboratory preparation kits. Genomic DNA was clipped to 450 base pair mean insert size using the ultrasonicator. The inserts were ligated with blunt ended, and a sequence alignment and skip folding. The libraries were denatured and pulled in groups of 8 for clustering and sequencing. Demultiplexing was performed using BLC2 fast Q, and all the mismatches were assigned to barcodes. The sequence quality was again checked using fast QC package and mapped against the latest chicken genome, GALGAL6. The variant was called using GATC, GATCK, and the SNPs within those 4 genes were extracted given the locations in GALGAL6, the latest assembly of the chicken genome, and the locations and the chromosomes are given in the table. SNP filtering was done using Blink 19. The method of filtering was done using the missing genotypes rate of more than 20%. And the minimum SNP quality was set at 25% missing genotypes, and Hardy-Wellbach equilibrium was called at more than 95%. Heterozygosity was done at more than 0.4%, and minor allele frequency was done at more than 0.05%. The TASOL software was used to estimate the pairwise linkage disequilibrium, and after pruning, we had 426,658 independent SNPs. The statistical analysis was done to find the effect of ecotypes and sex. The effect of ecotype and sex was performed using SAS. We used the methods, the ANOVA and GLM procedures, and least significant means was used to see the difference between the different means of the ecotypes. After the analysis, in the first analysis of the phenotypic data, we used 193 observations because some were missing. The model is given. Yes.
We are all interested in conclusion. Would you conclude?
Okay. Okay, the model is given. For the genotypic data, that is the SNPs, to check the effect of the SNPs on body weight, I have an animal model given there. The parameters are given in the results. The descriptive statistics are given with the ecotypes, the different ecotypes, the 6 ecotypes I looked at. I looked at the mean, the minimum, and the maximum body weight. And I found that the average body weight differed between the males and female, a condition or a situation called sexual dimorphism, which is basically caused by differential expression of the growth hormone between the males and the female. In terms of the effect of ecotype and sex on body weight of the chicken, there was significant effect of sex and the ecotype on the body weight. Age had been fitted as a covariate into the model.
I'll stop you if you don't summarize.
Yes, I'm finishing. I think I only had left with the last slide. And the ecotype, the ecotype and sex combination was not significant. In terms of association of SNPs in those genes with body weight, there were 9 SNPs that were significant from all the 4 genes. The first picture on the left upper one is BMPR1B, and the only significant SNPs was this one at the upper part. And for DRD2, there were 2 SNPs which were significant. For male 1C, there were 3 SNPs that were significant. And for NPY, there were 3 SNPs that were also significant. So on my conclusion, body weight varies in terms of sex and also ecotypes, the ones that I studied. The SNPs within those 4 genes were associated with body weight traits, and potentially these SNPs can be used for marker-assisted selection. And the 4 genes can influence the variation of body weight. So thank you so much.
Thank you, Muge. Thank you. We'll interact with you later in future. I bring this presentation to an end in the interest of time. I'm told your cocktail is ready. Kindly go down for your cocktail. Thank you.
Ajai change, leo jana na tomorrow. Tushahidi shugali chumvi na tudoro. Sana nipa plenty, aje sa tomorrow. Na shingo ni togoro from Mabati. Na invest uogoro ni so much.